yeah, you're right.
Plus, there is a demand to do one of the problems from the other worksheet. We couldn't get the answer.
Yeah,
What's yours
number,
say?
Gradients worksheet.
number 5.
Okay, so let's start by doing that. Number 5
Oh,
on
yeah.
MVC 7.
Yeah.
Didn't we start it?
Yeah. Yeah, what?
I got these.
Nobody could finish it.
Yeah.
Park, did Park get it?
No.
Oh, shit. I pity some of you on this test then.
Well, none of us know how to do it.
Isn't it just algebra after the first step?
Very complicated.
Oh gosh, complicated algebra. All right,
Oh.
find the maximum volume for a rectangular solid inscribed in the ellipsoid x squared over a squared plus y squared over b squared plus c squared z squared over c squared equal 1. So didn't we already determine the volume is 8xy?
Yes.
Z.
Yes.
Okay, so what do we need to do?
Solve for z.
Yeah, but we need to solve for z, yeah? Actually, what we're gonna learn today will kind of take care of this problem, but we
Yeah,
didn't
that
learn
solves
it.
it.
Yeah, but we didn't learn it yet. So solving for z squared is equal to, let's see if I can do this, c squared times 1 minus x squared over a squared minus y squared over b squared. So z is equal to square root, which is c, assuming it's in the first octant, square root of 1 minus x squared over a squared minus y squared. Didn't we simplify this the last time too?
Well, yeah, but then I
Okay,
tried to do something.
least common denominator, a squared, b
backwards,
squared, so you're gonna get a squared, b squared, minus b squared, x squared, minus a squared, y squared, correct?
Yes.
But then this thing can come out as an ab, and so you're just gonna get the square root of a squared, b squared, minus b squared, x squared, minus a squared, y squared.
Yeah.
So this becomes 8 x, y,
C.
and z is equal to this thing here. So what do we got? C over AB times a squared minus b, no, a squared b squared minus b squared x squared minus a squared y squared. Right?
Mm-hmm.
Okay, so we do the gradient.
To the 1/2.
What?
To the 1/2.
Oh yeah, to the 1/2. So this is a constant with that, so why don't we just put the 8 over there, and that's the constant. Okay, so gradient of v. Gradient of v, what is the x component gonna be?
Oh,
So, throw the constant on the side like an unwanted pet. We take the partial with respect to x, so we're gonna use the product rule. So, derivative of the first, leave the second one alone. A squared, b squared, minus b squared, x squared, minus a squared, y squared to the half, plus, leave the first one alone, xy, take the derivative of the second, 1/2 a squared, b squared, minus b squared, x squared, minus a squared, y squared to the negative half, times the derivative of the box with respect to the negative 2 b squared x, is that correct? You guys better check my work, man.
negative 2b squared. Oh, yeah. Yeah, that's correct.
And then the partial with respect to y will be 8c over ab times derivative of the first, so it'll be x times a squared b squared minus b squared x squared minus a squared y squared to the half, plus, leave the first one alone, 1/2 a squared b squared minus b squared x squared minus a squared y squared to the negative half times the derivative with respect to y, which is negative 2a squared y. Is that correct? Setting each of the components equal to 0. Okay, where did I didn't put the bracket, I didn't finish the bracket there. Okay, now it's correct. Okay, setting each of the things equal to 0. Let's see if we can clean up some things so we don't have to write them all out. I can get rid of the constant then, yeah? If you set it equal to 0.
Yeah.
Yeah, because if it's equal to 0, then just divide both sides by this, right? Anyway, it's a constant. The constant not going to be 0.
Can you divide everything by a squared, b squared minus?
Yeah, well, look. Okay, so since this is negative and you can set it equal to 0, so therefore y a squared b squared minus b squared x squared minus a squared y squared to the half gotta equal to, the 2's cancel out, and so you're going to get b squared x squared y times a squared b squared minus b squared x squared minus a squared y squared to the negative half, right?
Yeah.
And then can't you, okay, y cannot be 0, so you can divide both sides by y. And then isn't this, basically multiply both sides by this thing to the 1/2, so aren't you gonna get a squared b squared minus b squared x squared minus a squared y squared is equal to b squared x squared?
Is it?
Yes or no?
Oh, yeah.
No? Then you can solve for x squared.
But like,
Well, you can either solve for x squared or y squared. You know what, why, tell you what, why don't we just leave this equation alone here, and then maybe we can, after we simplify the second gradient of the second component, maybe we can somehow combine them together into something good. So the second one gonna be x a squared b squared minus b squared x squared minus a squared y squared to the half is equal to, the 2's cancel out, so you're gonna have a squared x y squared, is that right? Yeah, times a squared b squared minus b squared x squared minus a squared y squared to the negative half. So the same reasoning, the x squared, x's cancel out, x cannot be 0, so you just have a squared b squared minus b squared x squared minus a squared y squared is equal to a squared y squared. So we got this one right here.
it's not the same thing.
Yeah, so since this is equal to this, therefore this gotta equal that. So if b squared x squared is equal to a squared y squared, then wouldn't y be equal to plus or minus, but if we assume in the first octant or whatever, no, that's not right. Bx over a.
Oh, that looks correct. I got y equals x. Okay, never mind.
Okay.
Yeah, did you guys get that?
Yeah.
You did? Wait.
Isn't it just?
Look, right, you guys understand, if this equals this, therefore that gotta equal that, right?
Yes.
And then you square root both sides while assuming everything positive, and then you get that. Okay, now, we figured out, okay, now what do we gotta do? Don't we have to plug it back in? Which one you wanna plug it back into? You wanna plug it back into this one or that one?
Well,
The bottom one. Well, if we're solving for y, this one only has one y term right there.
so the first
In fact, why did we solve for y? Why didn't we just solve for y squared? The same thing, yeah. Okay, so here we go, right here. A squared b squared minus b squared x squared minus a squared, but what is y squared equal to? B squared x squared over, ooh, it's coming out, equals b squared x squared. The a's cancel out. So a squared b squared is equal to, you got a negative b squared x squared, a negative b squared x, put it on that side, 3b squared x squared. B squareds cancel out, so x squared is equal to a squared over 3, therefore x equal a over root 3. Plus or minus, but again, we're assuming positive. Remember, the point is in the first octet, that's why.
Now you gotta solve for z.
Wait. So now that we got x, how can we figure out y? Plug it back into this one, right? So y equals b over a times x, which is a over root 3. So that's just b over root 3. And then now we gotta figure out, what, we have to find the maximum value? Yeah, so now we gotta figure out z. Well, once we got a, x, and y, don't we just go back to this one to figure out z? Okay, I'll do it. Z is equal to c over ab times the square root of a squared b squared minus b squared times x. What is x squared? A squared over 3 minus a squared times y squared. What is y squared? Where's y?
B squared over 3.
Wait,
No I line.
b squared over 3.
Yeah.
Okay, now let's simplify that. C over AB times the square root of a squared b squared minus a squared b squared over 3 minus a squared b squared over 3. So that's equal to c over AB times the square root of a squared b squared over 3. Right? Because if you make a least common denominator, you're going to get like that, right? Okay, and then, so that's equal to c over AB times AB over root 3, haga, c over root 3.
Or Z.
That's the z coordinate. Oh, look at the symmetry of it.
Should have just guessed that from A, B.
So therefore, the biggest volume then is going to be 8 times x. What is x again? A over root 3, y was b over root 3, and z was c over root 3. So you get 8abc over 3 root 3. Cartouche! Is that the answer?
What's the maximum? Well, you don't have to.
What number is
Oh,
this?
yeah, it is correct.
5. Yup, that's the answer.
Oh my.
That wasn't that. I thought somebody said it was tart.
Oh,
It is.
That's just simple algebra. Okay, medium algebra then.
I don't think they give that to algebra.
Okay, then maybe not algebra. But it is algebra 1 though, if you think about it.
We don't understand.
Woo! Okay, so you can see the lengthy process that we have to go through.
Is that on the test?
Yes.
Wow.
No, but there's gonna be, we're gonna learn something today that kind of takes care of this.
Also, that's not on the test.
It is on the test. So what is today's lesson then? Today's lesson, if you look at the net, this is the last worksheet. I'm gonna make it bigger so I can actually read it there. And I'll even do one of the problems then. So if you guys are following along in the video, we're on MVC 8. So look at that, this is a, look at the wisp of wiles right there.
The what?
The wisp of wiles. I told you, when I make a mistake, I just cross it out and then I call it something like the nebula of Newton. Or the
Was
gas
that
of...
real? Like,
No, I just named it after mathematicians. You know, try to make alliteration.
What is a wisp?
You know what a wisp is? It's like
That
a
was so
like a
wisp.
ghost.
A what?
It's like a
What?
ghost.
Yeah,
Yeah.
yeah, see, it's like a amorphous shape or something. Anyway, if the vector x naught maximizes or minimizes f of that vector subject to the side condition g of x equals 0, then the gradient of f and the gradient of g are collinear. That is, you guys know what this means, right? I.e., that is,
That's what
For
it stands
example?
for? I never knew that's what it stood for.
yeah, no, that is.
That
How
is.
does that stand
Why is it
for?
IE then?
It's Latin for something.
I thought it was like for example.
No, for example, it's e.g.
I always knew I used it wrong, but I wasn't sure how I used it
E.g.
wrong.
is for example, I.e. means that is.
I
See,
don't
that
know.
is-
I just ignored.
The gradient of f is equal to lambda times g of x. Wait a minute. This is wrong. There should be a gradient symbol before the g.
That's a problem.
the scalar lambda is called a Lagrange multiplier, and you can see why they use lambda, right? For the mathematician Lagrange, since lambda is the Greek letter for L.
IE stands for it asked. It asked. IDE.
But it means that is, right?
And
That is.
yeah,
Yeah.
I think that is.
Okay. So why don't I do one problem so you can see how it works? You know what? I'm gonna do an easy one, number 1.
No.
Yes.
You didn't-
1 and 2 are 2-dimensional. Okay. You want me to do number 3 then?
Also, Park, think how much time you would save if you did like number 5, because I'm gonna ask you about it.
Mm.
No,
That's great.
but you guys need to try that because that's the kind that's gonna be on the test. In fact, I made the test the other day. There's something like number 5 there.
You gotta circle that?
Okay.
No, can't I just do a 2-dimensional one and then you can extend it to 3 dimensions? Okay, I'll do the number 3 then.
It's better if you do more advanced ones so we can do the.
Okay, we want to minimize the product x, y, z on the sphere x squared plus y squared plus z squared equal 1. So isn't this similar to the problem that we just did? We're trying to maximize the volume, which was 8xyz,
Okay.
with a side condition that, what was the equation of the ellipsoid? With the condition x squared over a squared plus y squared over b squared plus z squared over z squared equal 1. Remember that? So this is like the same problem, except this is a different way of solving it. We're going to use a Lagrange multiplier here. So what is the function that you want to minimize here? X, y, z. You know what? Maybe we should actually do that problem afterwards.
Wait,
Do which problem?
No, I'm not gonna. What?
is this 2 constraints?
No, it's called maximum or minimum with side conditions. Look, this is the quantity we want to minimize
Okay.
with the side condition that
On the
x squared plus y squared plus z squared is equal to 1. So in other words, we have a sphere of radius 1, center at the origin. So if you pick any point on the sphere x, y, z, what point can you pick so that if you multiply the 3 together, you get a minimum?
Okay.
So you can't, you pick or can't?
No, you wanna,
Yeah, yeah.
what point is there on the sphere
And then
that so that x times y times z will be a minimum value?
Okay.
In fact, you
Wouldn't
can
it
do,
be just on like 0, 0?
no, because can't it be negative? Negative can be smaller than 0, that's why, right? So maximum or minimum. In fact, why don't we do both then, maximum and minimum?
Okay.
Okay, so the first thing is, okay, so this is F, and then G is the side condition, except you gotta make one side 0. So G would be x squared plus y squared plus z squared minus 1. That's what G would be. Compute the gradient of each one. What is the gradient of F? Come on.
1, 1, 1.
No.
No.
Easy.
YZ,
Oh yeah.
and then XZ, and then XY. Then what's the gradient of G gonna be?
2x.
2x, 2y, 2z. Correct? Okay? So we're looking for something so that this vector yz, xz, xy is some multiple of zx, no, that's 2x, 2y, and 2z. Well, if, so the theorem says the vectors need to be collinear. In other words, one has to be a multiple of the other. So this has to be true in order to get a maximum or a minimum. So why don't we break it down by component? So therefore, yz got to equal to 2 lambda x, correct?
Yeah.
If you just look at the x components. And the y component, xz got to equal to 2 lambda y, and then xy got to equal to 2 lambda z. Now you have to find some way of solving this, these three equations. Does anybody see a way?
Solve
We
for lambda.
can-
Solve for lambda.
Oh,
I guess you could do that, but how about, for
Yeah,
example,
why
how about
is-
multiply, look, This is YZ, this is XZ, this is XY.
Oh, the multiply the first one, divide by.
Well, how about just multiply the first one by X, multiply the second one by
Oh, and then mash
Y,
them together.
multiply the third one by Z, that way you have XYZ, XYZ, so you can equate the right sides of the equation.
Well, can't you just do YZ over X equals XZ over Y? or something?
Yeah, that's the same.
Is that the same thing?
Yeah, because they're all equal to 2 left. So
Solve for
because if you
one.
divide the first one by X and then the second one by Y and the third one by Z, then you can still equate them.
So you just because YZ over X equals XZ over Y equals XY over Z.
Okay, maybe you can do that, but that's not what I thought of.
Okay.
XYZ is equal to 2 lambda X squared if you multiply both sides by X. I don't know, maybe your way might be better. Multiply both sides by Y. XYZ is equal to 2 lambda Y squared, and then multiply both sides by Z. XYZ is equal to 2 lambda Z squared. So, since XYZ is common to all, so 2 lambda X squared got it equal to 2 lambda Y squared, got it equal to 2 lambda Z squared. So therefore, X squared got it equal, Y squared got it equal to Z squared.
So one's 1 over root 3.
Yeah, so, oh, see, so this is kind of easy because the sphere is so symmetrical, yeah? So taking these and plugging it into the side condition over here, why don't we solve for X? So X squared plus X squared plus X squared equals 1, 3X squared equal 1, X squared equals 1/3, X equals 1 over root 3, if we, well, it's actually plus or minus, right? I think we better use plus or minus in this case. So therefore, what is Y then?
Plus or minus.
Plus or minus 1 over root 3 as well. And then Z would also be plus or minus 1 over root 3. So what's the question? It says minimize. So to get this to be a minimum, what has to happen?
Has to be
1 or
negative.
3 of them.
It's got to be either 1 or 3 of them got to be negative. So the minimum value would be negative 1 over 3 root 3. And then what about the maximum?
Positive.
Yeah, the maximum, they would all have to be positive, or 2 of them gotta be positive. So we would get 1 over 3 root 3. That one's kinda easy because the sphere is so symmetrical. There's gotta be a better one. I think number 5 is probably gonna be the best problem on there. Now, I was thinking, you guys wanna try that on the problem we just did?
Wait, sorry.
No. Okay, no then. But so you understand how to set up the problem? So you got the function you're trying to maximize or minimize. This is the side condition. So what you do is, the side condition, you gotta make one side 0, compute the gradient of both, and then one gotta be a multiple of the other.
Does that
And
make,
then you just gotta manipulate the equations.
does that make the other one really easier as it's so the same involved algebra?
I don't know, that's what I was thinking.
Yeah.
I think it's the same thing.
Did you try it?
Oh no.
Did you try it?
The one
We just
right now.
did. Okay.
Wait, Mr. Bart,
What?
I didn't try
Yeah.
it. It's
after
zero.
after this said what did you do? The X squared equals Y squared minus.
Yeah, so once you solve for something here,
No, I
you have to
think
plug it into the side
It's
condition.
not.
The side condition.
Oh, okay, and then Y squared it equals X squared and
And Z squared equals
let's say
X
you
squared.
okay.
Yeah.
So you could have done Y2.
Okay, just to satisfy me, why don't we try it then? I kind of forget
I
the
think
problem.
it's harder
You sure?
because it looks
Oh, we gotta erase. We're gonna have to erase because
pretty wild.
No.
too late. Well, watch the video. Freeze frame.
The side can.
Okay, what was the problem? We're maximizing the volume 8xyz with the side condition ellipsoid, x squared over a squared plus y squared over b squared plus z squared over c squared equals 1. Is that correct?
I think so.
That was correct, yeah? So this would be like the f, and g would be this, but you gotta make one side 0. Okay, so what's the gradient of v? We'll call that f then. What's the gradient of f?
8YZ and so on.
And so on.
Yeah.
xz, and then 8xy. Correct? What's the gradient of g? 2x over a squared, 2y over b squared, 2z over c squared. Did I do that correctly? Now one gotta be a multiple of the other, right? So 8yz, 8xz, 8xy gotta equal to lambda times 2x. I could have skipped this step. 2y over b squared. You gotta tell me when I'm making a mistake here. So equating each of the, the components, 8yz gotta equal to 2 lambda x over a squared. 8xz gotta equal to 2 lambda y over b squared. And 8xy gotta equal 2 lambda z over c squared. So why don't we just do the same thing we did last time? Multiply this equation both sides by x. Shall I go 2 goes into 8 4 times? Too late, I did it. 4xyz is equal to lambda x squared over, yeah, can you see it's coming out already? Multiply both sides by y, so you get 4xyz is equal to lambda y squared over b squared. And then 2 good to go 4, multiply both sides by c, 4xyz is equal to lambda z squared over c squared. So therefore, lambda x squared over a squared gotta equal to lambda y squared over b squared gotta equal to lambda z squared over c squared. Divide by, b squared, divide by the lambdas. So here's your side condition, equals 0. So shall we put everything in terms of x again? So x squared over a squared plus, what can I substitute for b squared? Oh, right here. Y squared over b squared is equal to x squared over a squared plus x squared over a squared equal 1. 3x squared over a squared equal 1. X squared is equal to a squared over 3, x equal a over root 3. That was a lot faster. Isn't that the same thing we got on the last one? Yeah, so yeah, it is a little faster, but you still gotta do some work. But some of these steps can be skipped, so yeah, this is a lot faster. So this method of Lagrange works really well. Because on the test, I'm not gonna tell you what to do, you just gotta do it.
Okay,
Well, how do you know what to do, like which one to do?
Well, you have to be given a side condition. See, you wanna maximize this, and this is the side condition. That's when you use the Lagrange multiplier. All right, so let's see how you guys fare on those other 4 problems that I didn't do then. See, isn't this a lot better than just doing start problems?
Why do you have the x's
Yeah.
in there on the bottom one on the right?
Where?
The x.
That's
Oh,
just
those
lambda
lambdas?
being
That's
constant.
lambda.
Okay.
Lambda, 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 and cancel them out.
That's it?
Yup. It's
Oh.
on. Yeah, but you know what? The most fun chapter is going to be next chapter when we do double and triple integrals.
Oh, yes.
And then we're gonna integrate in the cylindrical and the spherical coordinate system. I hope you guys remember something about that from PCH.
Cylindrical and
Don't worry, we'll review it before we do it.
So,
And then you guys are taking physics now, or you took it already?
yeah.
We're gonna